Unit 4, Objective 5. My first example is going to help you with the first two problems on the worksheet, the work problems. Ben and Caitlin work at an electronics store. A client needs to have his office computer system completely upgraded. Working alone, Ben will take 20 hours to design and replace the system. Carolyn, working alone, will take 16 hours. How long in hours will it take to design and replace the computer system in the office if they work together? Well, this problem is simply going to be an addition problem because we're going to take Ben's rate at which he can work. Now, he can get the job done alone in 20 hours. So Ben is going to be represented by the fraction x over 20. Now, Carolyn is a little bit more efficient. She could do the job all by herself in 16 hours. So Carolyn is going to have a rate of x over 16. How long is it going to take them if they work together? Well, working together is going to be a plus. And the number that represents the job getting done is the number 1. So that's the setup to the problem. In fact, that's the setup to every work problem that's like this. You know what it's going to take for this guy to do it alone. You know what it's going to take for this one to do it alone. But if they work together, what's it going to take? How long is it going to take for them to get it done? So we've got this equation right here. Since it is equation, the key is going to be to clear the denominators. Now, we could always use whatever 20 times 16 is, but there is a better number than that. And I believe that number is 80. The least common multiple of 20 and 16 is 80. So what I'm going to do is I'm going to multiply the entire problem by 80. Now, what that makes is 80x over 20 plus, remember I'm distributing, 80x over 16. And don't forget the 1 needs the 80 also, so 80 times 1 is 80. Now at this point, I promise you the fractions are going to reduce. So the 80x over 20 is 4x. The 80x over 16 is 5x equals 80. Now, combine like terms, 4x plus 5x is 9x equals 80. Divide both sides by 9. X equals 80 over 9, which is 8 and 8/9 hours. So together, it's going to take them 8 and 8/9 hours to get the job done. The next example we're going to work on is going to help you with problems 3 and 4, average cost problems. Now, this is the concept that, in my opinion, is the hardest to do on worksheet 5. Initially, a group of students, X, have hired a chemistry tutor to help them prepare for an upcoming test. The cost for the tutor is $112. 2 more students are going to join the group, which lowers the average cost for each student by $1. How many students were initially in the group? Now, here's the key to the entire problem. In words, We're going to start off with the average cost per student of the original group. Well, in this problem, it would be the cost of $112 divided by the number of students, which is unknown. But then something happens. There's an adjustment of some kind. It turns out 2 more students join the group, which brings the cost per person down. Now, if two people had left the group, then that would mean the average cost would go up. But let's go back to the problem. 2 more students are going to join the group, which lowers the average cost. So 2 more students join the group, which is, and by doing so, they lower the average cost by $1. So the adjustment is going to be -1. It's still going to cost $112, but there are 2 more students than before. And so there's your equation right there. The original group, $112 divided by the number of students who were in the original group. The new group, $112, but there are 2 more students in the group than before. And what did that do? That lowered the cost for each student by $1. So here's the setup for the problem. Okay, now that we've got the problem all set up, let's start solving it. We're going to want to clear all the fractions. So in order to clear the fractions, we're going to multiply each term in the problem by the least common multiple, which in this case is x times x plus 2. So if we take the first term, which is 112 over x, and we multiply it by x times x plus 2, the x down on the denominator and that x are going to reduce each other. And so the only thing you're going to have left in the first term is the 112 multiplied by the x plus 2. Now, if we take that same x times x plus 2 and multiply it by -1, there is no denominator under this -1, so nothing's going to reduce or cancel. So it's -1 times x plus 2 equals, now I'm going to do it one more time. I'm going to take that x times x plus 2, and I'm going to multiply it by 112 over x plus 2. Well, the x plus 2's are going to reduce, and the only thing you're left with is 112x. So here we are after we have now cleared the fraction. Now it's just a matter of start cleaning this problem up. I'm going to distribute 112x plus 224 minus, now x times x plus 2 is x squared plus 2x. So it's minus x squared plus 2x equals 112x. I still have some cleanup to do. 112x plus 224 minus x squared minus 2x equals 112x. Now, I've got 112x on this side, and I've got 112x on that side. So those two can cancel each other. Now, I'm left with 0 over here, which is what I want because I've got a quadratic. If I rewrite this quadratic, it's negative x squared minus 2x plus 224 equals 0. I really don't want that x squared to be negative, so I'm going to divide all the terms by -1, or you could say I'm going to factor in -1 out of the problem, but it's just going to change all the signs. X squared plus 2x minus 224 equals 0. So here's my trinomial. My next step is going to be factoring. Now this problem does happen to be factorable. In fact, they're all going to be able to be factored, but sometimes they're going to be really hard to see. So remember, you can always default to solving a quadratic equation by using the quadratic formula. So let's say you didn't want to play around to figure out what two numbers multiply to give you -224, but their sum is +2. And you can just go to the quadratic formula to get this answer. So let's say that's what we're going to do. X equals the opposite of the b value, so -2 plus or minus the square root of b squared, so 2 squared would be 4, minus, now I'm going to do 4 times a times c. 4 times 1, because that's the a value, is 4. But then I need to multiply it by that -224, which is the c value. So -896. All over 2 times the a value. 2 times 1 is 2. So x equals -2 plus or minus the square root of, now when you subtract a negative number, it becomes positive, so we're really adding 4 plus 896 is 900 divided by 2. X equals -2 plus or minus the square root of 900 is 30 divided by 2. Now I'm going to do both operations. I'm going to take -2 and add 30, and you're going to get 28. And divided by 2 equals 14. I'm going to take -2 and subtract 30, and you get -32 divided by 2, and you get -16. Now you have to remember what x represented in the first place. It was the number of students who were initially going to hire the tutor. And I can't have a negative amount of students, so I throw that answer out. So my answer is 14. So 14 students in the original group. And that's your answer. The entire back page of worksheet 5 is all about using formulas that have more than one variable in them and solve for a certain variable. So this first example I've got for you is a formula that says 2L plus 2W equals P. You may recognize this equation. It's all about a rectangle. A rectangle has a length down here and a length up there and a width over here and a width over here. And if you wanted to find the perimeter would be 2 L's plus 2 W's. Now, what if I want to solve for L in this problem instead of solving for P? The first thing I do is move the 2 W's. So subtract 2W, subtract 2W. And at this point, your equation would be 2L equals P minus 2W. And if I want to solve for L now, L is being attached to the 2 with multiplication, so we're going to reverse that process, which is divide. So I'm going to divide both sides by 2. And I'm going to come up with an equation that simply says L equals P minus 2W over 2. And that's our answer. So really, all we're doing is we're doing the exact same algebra steps we would be doing if these were numbers, but they're not. They're not numbers. They're variables. This second equation tells us how to convert temperature from Fahrenheit to Celsius. So right now it's being solved for Celsius. But what if we wanted to solve it for Fahrenheit? Well, I've got Fahrenheit minus 32, so if I want to isolate that Fahrenheit, I'm going to have to add 32, but that isn't what I'm going to do first. The first thing I'm going to do is get rid of that leading coefficient of 5/9. Now, the easiest way to get rid of 5/9 is multiply it by 9/5. So that's what I'm going to do. I'm going to multiply this side by 9/5. I guess I'll put it right here. And I'm going to multiply this side by 9/5. Now, what I've got here is 9/5 C equals, now, the new 9/5 multiplied by the 5/9, the reason I used the reciprocals would be so they reduce each other down to 1. So now all I've got is F minus 32. And if I'm solving for Fahrenheit, now all I have to do is add 32. The whole goal was to get Fahrenheit all by itself, and now I have it. 9/5 C plus 32 equals F. And that was my goal, to solve for F. Now, this equation right here, the circumference of a circle equals 2 times pi times r. If I want to solve for r, I just need to get the 2 and the pi to go away. Now, since I could do this in 2 steps if I want, but I'm just going to do it in 1. R is being multiplied by 2 and pi. So the way I'm going to get rid of them is I'm going to divide. So C over 2 pi equals r. And now I've solved the problem for r. This next problem is a formula that's actually used in my AP statistics book. It revolves around the budget for a classroom. Every classroom gets $50, plus it gets $20 for every student over 10 students. So I want to solve for student. First thing I'm going to do, I've got a lot of things to do to get this S by itself. First thing I need to do, I'm going to get rid of this 50 right here. I'm going to subtract that 50. So now I've got B minus 50 equals 20 times S minus 10. Now, the next thing I'm going to do is I'm going to get rid of that 20. So I'm going to divide both sides by 20. And that gives me B minus 50 over 20 equals, now the reason I divided by 20 was to get that 20 to go away, and I'm left with S minus 10. So now I'm only one step away from having S by itself, and that would be add 10 to each side. So I'd be left with B minus 50 divided by 20 plus 10 equals S. And that would be the same equation. These are equivalent equations. Only thing is, in its presented form, it was solving for B, and I changed it to where it's being solved for S. Now this last problem, 1 over x plus 1 over y plus 1 over z, if I want to solve for z, okay, the key is multiply all terms by the least common multiple, which would be x, y, z. So that's the key to the problem. The entire problem needs to be multiplied by x, y, z. So it's like a triple distribution. Now, since every one of those numerators is a 1, it kind of makes the problem pretty darn easy. 1 times x, y, z would be x, y, z. This one would be over x, plus 1 times x, y, z would be another x, y, z. This one would be over y. 1 times x, y, z would be x, y, z. And this one would be over z. Now, the reason we multiplied by the least common multiple is whenever you multiply by the least common multiple, you will always get the fractions to go away. This first one, it's the x's that reduce. The second one, it's the y's that reduce. The third one, it's the z's that reduce. So look at the equation we've got now at this point. We have yz plus xz equals xy. Now we're solving for z, and we have two z's right here. So we're going to have to factor it out. There's a greatest common factor of z. So if I factor a z out from the left-hand side, I'd be left with y plus x equals xy. And by factoring out that z, I've now created only one z instead of having two of them. So to get this z by itself, all I need to do is divide both sides by x plus y. And on the left-hand side, now those x plus y's cancel each other, and I'm left with z equals xy over x plus y. So really, all you're doing is you're doing all the algebra steps you would normally do with numbers, but you're doing them with variables now.